Question 16 from the review packet here. Given the polynomial function f of x is equal to x to the fourth plus 5x cubed plus 5x squared minus 5x minus 6, determine the following. All right, now this looks like it's got a lot of effort into it, but really it isn't, because some of these things we can do pretty quickly. For instance, the y-intercept. The y-intercept happens when x is 0. So if x is 0, the only thing that's left over is negative 6. So our y-intercept is going to be 0, negative 6. See, we just answered that question pretty quickly. The next part, what's the degree of this polynomial? What's the highest power in this polynomial? It's 4. The zeros, that's going to take some effort. We'll have to come back to that one because really what they're talking about are the x-intercepts. The end behavior, all right? It's positive x to the fourth, which means as x goes to positive infinity, it goes to positive infinity, meaning it goes up if you remember. As x goes to negative infinity, it also goes up. Remember our endpoints on this case goes up on both cases, right? It's even and it's positive, which means that left goes up and right goes up, which basically means positive infinity for us. So that's how we're going to answer part D. So really the work in this problem happens in part C. What are the x-intercepts and an E to graph the function itself? All right, so let's go back to the zeros. We need the P over Q method. So our P is going to be 6, and our Q is going to be 1. So the factors of P are 1 and 6 and 2 and 3. And the factors of Q are just 1, meaning that our zeros to try, our possible zeros, are plus or minus, and it's 1 over 1 or 1, 2 over 1 or 2, 3 over 1, and 6 over 1. So our zeros are 1, 2, 3, 6. We have 4 of them more than likely because it says x to the fourth. All right, so let's do some synthetic division in the upper right-hand corner here. Let's try positive 1, always a good value to start with. We're going to have 1x to the fourth, 5x cubed, 5x squared, a minus 5x, and a minus 6 in our house. Draw the line, bring the 1 down. 1 times 1 is 1, 5 and 1 is 6. 6 times 1 is 6, 5 and 6 is 11. 11 times 1 is 11. Negative 5 and 11 is positive 6. 6 times 1 is 6, and looks like we just found one of the zeros. So one of our zeros here that we're going to put down, we'll put it just above here, is going to be 1, 0. All right, so then let's redraw our box right here because this hit, and let's try negative 1. 1 comes down. 1 times negative 1 is negative 1. 6 and negative 1 make 5. 5 times negative 1 is negative 5. 11 and negative 5 is positive 6. 6 times negative 1 is negative 6. And we just hit another 0. Negative 1, 0 is another 0 here. So then what's left over? Well, we have x squared plus 5x plus 6 equals 0. We should be able to factor that. How about x plus 3 times x plus 2? 3 times 2 makes 6, and 3 plus 2 makes 5. So that means x is going to be negative 3 and negative 2. And so those are other two zeros here are going to be negative 3, 0 and negative 2, 0. So we've got our x-intercepts now, and now we can actually graph it. We've got everything we need to graph this. All right, let's start with the y-intercept at 0, negative 6. So 1, 2, 3, 4, 5, 6 right there. Put a big dot. Then we've got our x-intercepts at 1, 0. 1, 0. Negative 1, 0. Negative 3. So 2 and 3. And actually negative 2, 0 as well. Awesome. We know what our ends are doing. The right goes up, the left goes up, based on the fact that it was positive x to the fourth to begin with. How does our graph get from 1 down here to negative 6, down back to negative 1? There's only one path it can take. Didn't ask for it, but how many turning points does this have? Let's put it over here. Turning points, remember, that we talked about, is the highest power 4, minus 1, always minus 1, so 3. So it should have 3 turning points here. So from 1 down to 6, negative 6, and then back up, there's 1 turning point. So here's going to be 2 turning points. Here's going to be 3 turning points. So 1, 2, 3 turning points. And there's what our graph looks like. Pretty good, huh? I like it. And you've just done number 16 from the review packet.